Hello everyone, let's take a look at today's LeetCode daily challenge. This is a very common problem. It used to be asked in interviews a lot until it became common, and everyone knew about it. You are climbing a staircase. It takes n steps to reach the top, so n steps. In each time, you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So if we have a staircase, I'm gonna show the staircase like this. So the length of this is n. This is a staircase, okay? And in each step, we can do a 1 jump, or a jump of length 1 or a jump of length 2. And we want to count in how many distinct ways we can climb the staircase. So whenever you are facing a problem that you can do a few different things and you don't know which one to take or how to calculate each one, you have some sub problems, you have some decisions to make. Like here, for the first step, you see, for the first step, we have a decision to make and we don't know which one to take first. So in these problems, this should give you a hint that you can apply dynamic programming. And you can actually make each of those decisions one by one and then combine the answer. So in this case, it means, okay, I'm gonna take 1 steps. So if I take 1 step, then I have a smaller sub problem. So the length of the staircase becomes n minus 1. And if we call our function f of n is the function that is counting in how many ways we can climb this staircase if we take 1 step or 2 steps at each time. So if we take 1 step, there remains n minus 1 steps. So f of n minus 1 can solve this problem recursively. We don't care about it, how it's going to be solved, because it's going to be solved recursively. That's the beauty of a recursive call. You don't care. You just ask, hey, f, what is the answer to f n minus 1? And it's going to give it to you. And if you do 2 steps, you can call f n minus 2. And again, you don't care. This is beautiful. I love recursion because of this, because you can break a big problem, here n is a big problem, into smaller subproblems. This is why you can actually apply dynamic programming into this problem, because a big problem can be broken down into a smaller subproblem. And also, let's go and see if we call fn, what happens. So if we call fn, so fn is going to call 2 other functions, fn minus 1 and fn minus 2. So fn minus 1 and fn minus 2. Fn minus 1 is going to call fn minus 2 and f of n minus 3. And f of n minus 2 is going to call f of n minus 3 and f of n minus 4, right? So what is interesting here is that we have some overlapping subproblems. So if this is the problem, all of these are subproblems. It means they are problems of the same shape, but with a smaller size. So we call them subproblems. So now we have overlapping subproblems. What does that mean? That means if you look here, this is fn minus 2, because we are going to keep calling, right? And this is fn minus 2. So because of this overlapping subproblems, we can actually solve it once and reuse it next time. This is again good for a dynamic programming approach that you have overlapping subproblems. So And back here, so let's say you have fn minus 1 and fn minus 2. What do you do with them to find f of n? You just add them together. So f of n is going to be f of n minus 1 plus f of n minus 2. Oh, why? Why do you add them together? This is important. This is mathematic at play. So let's say this is of length n, and we want to climb this staircase, and each time we can take one step or two steps. So if we take one step, our staircase is going to look like this. So the first step is going to be 1 of length 1. And if we take 2 steps, the first step is going to be of length 2. So this is f of n minus 1, and this is f of n minus 2. So f of n minus 1 is counting all of the ways that we can climb n steps, but the first climb length is 1. And f of n minus 2 is counting all of the ways that we can climb. Sorry. F of n minus 2 is counting all of the ways that we can climb a staircase of length n minus 2, and we add a step of 2 in the beginning of it. And f of n minus 1 is counting all of the ways we can climb a staircase of n minus 1, and we are adding a step of 1 at the beginning of it. So it's going to be a 1 plus f of n minus 1, or a 2 and not plus, I don't know, and maybe, and f of n minus 2. So as you see, these are counting different things, different structures, because all of the structures here start with a 1, and all of the answers here start with a 2. That's why we can actually add them together. So that's I think enough for the explanation. Let's go and see how we can write the code. We can do a bottom-up approach or a top-down approach. I'm going to do both of them. So for the bottom-up approach, so n is going to be 45. So as an integer is enough. So int ways, I'm going to say 50. Let me have this const int max equals 50. Okay. And so in how many ways can we do? So 1. So ways of 1 is 1, right? And ways of 2 is actually, in how many ways can we climb a staircase of 2? So this is 2. So one of them is we just do a 2. This is one way, or we can do a 1 and then another 1. This is a 1. This is a 1, yeah. Okay, so f of 2 is 2. And now for int, we do a for loop from starting from 3. So these are called base cases. So in a dynamic programming approach, base cases are the ones that you can actually calculate with your hands, like calculate on paper. These are base cases. And then we do a for loop for int I equals 3, I is less than max, I plus plus. And I'm gonna make this 46. Okay. Ways of I equals ways of I minus 1 plus ways of I minus 2. That's it. And then we return ways of n. Okay, let's submit. Okay, let's go back and do this recursively. So I'm gonna just climb stairs. I'm gonna do this recursively. So if n is 1 or n equals 2, return n. So remember, these are the base cases. Otherwise, return climb stairs n minus 1 and plus climb stairs n minus 2. But there is some problem here. This is a recursive function without any memoization. Memoization is when you save the answer to some subproblem. Here, when you have overlapping subproblems, you save the answer to one of them once you actually calculate them. So in order to do that, what we can do is, first of all, this is going to get time limit exceeded because the running time of this is 2 to the n. Because we are calculating every subproblem and we are not reusing any answer. So I'm just going to show you this gets a time limit. Let me test this for 40. What about 45? Yeah, time limit exceeded. So in order to fix this, I can have a dictionary, for example, in this case, a private map int dp, and here if dp that so if dp contains that, return it. Otherwise, here first save it and then return it. Okay, so let's see. Now this should work. Yeah, so and we can submit. Okay, and there are other ways of implementing this. So instead of like having a map of dp, you can have an array. So int dp max, and then you initialize dp to -1. And if dp is not -1, that means it's already calculated, and you return that. And it's usually a better way of implementing memoization if you use an array, if it's possible. And yeah, that's it. So now my question of what my variation to this question is, what if instead of 1, 2, you can do up to k steps at each time? So here, this is the question. Either each time you can either climb 1 or 2 or k steps. In how many distinct ways can you climb to the top? So how do you solve this problem? How does your solution change if you are allowed to take up to k steps? That's the daily question for today. Please, if you like my explanations, like the video and subscribe, and let your other friends who are preparing for interviews know as well. Thank you very much.